Hello, this is Matthew, and welcome to the beginning of this series of videos on installing RAKF, that's RACF with a K, on our MVS 3.8 systems. So what is RAKF? Well, RAKF with a K, it's a play on the IBM product name RAKF with a C, the Resource Access Control Framework. And without a security product, such as RAKF, the MVS operating system has basically no security. It just has stubs that always say, yes, the user is allowed to do this. Wherever security product might say, you know what, that user actually doesn't have access to that resource. So what that means in reality is that if you've done a fresh MVS installation, maybe like me, you've just done a new sysgen using Jay Mosley's excellent MVS sysgen instructions, you're left with a system in which every user is able to view and edit every data set on the entire system. Now, for a multi-user operating system, that often is not what you want. Users can edit the system data sets. They can change system parameters in sys1.parmlib. They could actually change out the whole kernel, the MVS nucleus on your system if they wanted to. There's nothing stopping them from editing anything on the entire system. And they can also read other users' data if you're using your mainframe for payroll processing. You know, your developers and their user accounts shouldn't be able to read the confidential data in the payroll data set. So in reality, nobody would run an MVS system with no security product installed. Really, the only security capability that MVS provides out of the box are dataset passwords, which we do set in the Mosley sysgen instructions. We set an update password on the master catalog, so that if anyone or anything tries to catalog a new data set in the master catalog as opposed to one of the user catalogs, you'll get the message to the operator over on the MVS console requesting the password to update that data set. But dataset passwords aren't really a scalable security solution. If you have a bunch of users, right, you're not gonna make a password that all of the users in one group has to share to get access to data sets that only that group should access, right? That sort of thing. It's not a real mechanism that anyone would really use. So in reality, you're going to use a security product. And again, IBM has one called RAKF. That's a paid commercial product that is therefore not available to us for free in our free MVS 3.8 world. But some smart folks have written RAKF with a K that provides a lot of the similar capabilities. It will let us protect data sets on our system such that only certain users can read or modify data sets based on however we set up our profiles. So this is going to be a 3-part video series. This part 1, is where we will set our system up to install RAKF and then install the original base version of RAKF. Part 2, we will install the available PTFs, or the patches essentially, and updates for RAKF. So the original version of RAKF had a couple of bugs in it, as all software does. It didn't let users change their own password, or if the users did change their password change didn't survive past a re-IPL of the system. So kind of inconvenient for the users if they change their password and then it just reset to whatever the administrator set every time the system re-IPLs. There are some documentation updates. There's a utility called RACInd that we will read about in the documentation. That comes in a PTF later. And a couple of other things. Oh yes, the ability to add comments to the user table and the profile table where we set up all of the RAKF rules. So that's kind of nice to be able to comment, why you're adding rules, things like that. So that'll be part 2. And then part 3 is where we will actually customize and activate RAKF so that it begins enforcing security rules. And then we'll take a look at a couple of, how we can make some brief rules, and you can get an idea of that. And then the fun part is where you go off and you figure out, well, how do I want to secure my system? What do I want to secure? What users should be able to do what? And there's a whole art to that in itself. And I certainly can't claim to be an expert on how to properly secure a multi-user MVS system. But by the end of the 3 videos, you will have a working security system installed, and you'll at least know where to go to start adding rules to secure the system the way you want to. So without further ado, let's dive in. Actually, a little bit more ado. I should mention, if you've watched my videos before, you'll be familiar with this, but just quick orientation for those of you who haven't. Along the bottom here, I have the different terminal sessions that I have open. This is just GNU screen to multiplex my terminal here. So we have the Hercules console itself. So this is just the Hercules emulator console running. We have the MVS console that we can switch to. We have the MVS TSO session. So this is where we'll be doing most of our work. And then I have a Linux shell here. And this is on the system that this Hercules is running on. So this MVS 3.8 directory is actually where our MVS system is over on my Linux file system. There's also a web browser here in the background that we'll be using. So of course it will be obvious when we switch to the web browser. All right, and the last thing I should add is that this is a freshly built system using Jay Moseley's latest instructions. I just built this system yesterday for the purposes of this video, so it's the beginning of April of 2022. And I figured I would do this, and I just followed his instructions exactly. I didn't make any customizations. I didn't make any modifications. So I figured since we're installing RACF on here, if I did it on my own system where I've already made a lot of customizations and tweaks to his setup instructions, I didn't want to add any confusion if you followed his instructions and you're seeing something different. So this is a to-the-letter Jay Moseley April 2022 MVS 3.8 system. I should also add, in case you weren't aware, if you're using the TK4- system, RACF is already installed, so you don't need to install it. If you try and start following the instructions of this video, you'll probably actually mess up your installation and break RACF and not be able to access any of your data sets. So this could still be interesting for you if you are curious about how software like this gets installed. But if you're using TK4-, RACF is already included in that distribution of MVS. Okay, let's dive in. Now, the one sort of prerequisite thing we're going to install is Ind-File. That's IND$file. We're going to want to get some files into and out of our system later on. And Ind-File is probably the one critical utility, what I'd consider pretty critical, that Jay Moseley does not include in his default setup. And Ind-File is what allows us to use our 3270 emulator's file transfer capabilities to and from the mainframe. So I just find that to usually be the most convenient way to get files in and out of the system. But right now, if I log on as HMVS01, right, if my terminal emulator tried to start, not Ind-Term, but Ind-File, tried to start Ind-File to transfer a file, of course, Ind-File not found. So we will load that. I have a whole video, it's video number 14, on how to use Receive 370 and how to get Ind-File installed on your system. That's a 45-minute video unto itself. So if you are interested in the details, you can go watch that video. But since I do have that video on this whole process, I'm just going to very quickly run through the steps to get Ind-File installed on this system, because this video isn't about installing Ind-File, it's about installing RACF, but we're going to want Ind-File available on our system. Okay, so let's install Ind-File. We will grab it from the CBT tape website. This is cbttape.org. So you can just go to cbttape.org. You can go into the CBT section, And then if we search for $file, you'll see that we have file 607, a free Ind-File version from Mike Rayborn. So I'm just going to copy that link. And back over in my Linux shell here, let's go over to session 3. I will simply download that file. So it's cbt607.zip. All right, we got that. So we'll unzip it, cbt607, and that gives us file 607.xmi. So that's a transmit file. We use receive 370 to unpack that file on our mainframe. And because we don't have Ind-File yet, really the only way, well, there are actually several ways, but a convenient way to get this file up to our mainframe is to just have receive 370 directly read it out of the card reader. So let's go to our MVS console. And there is a spare card reader at device address 01C. So we'll devinet 01C with that, what do we call it? File. Oh, sorry, this is the MVS console. We should be on the Hercules console. Yeah, Hercules console, devinet 01C, and that's going to be file 607.xmi. So this is not the card reader that is handled by Jez2. This is the spare card reader that is just available for us to use from our jobs. So over in TSO, let's start up the review front end. We'll edit my data sets here. And in my control data set, I'm going to edit, we'll call it, receive Ind-File. As good as name as any, I guess. And we'll just write some quick JCL here that will use the receive 370 utility to read that transmit file from the card reader and stick the contents of that transmit file into a new data set under my HMVS 01 alias here. So this will be a job. I'll call it HMVS 01R for receive. And we'll want class A, message class X. The receive step. So there is a cataloged procedure for receive 370. The systems built using the latest version of Jay Mosley's instructions have his sysc or system compiler pack already integrated. And one of the cataloged procedures there is receive 370. So it takes care of everything except the transmit in and transmit out data sets. So super convenient. All we need to do is set up transmit in. And this is going to be the card reader. So this is unit, we said 01C. And we will tell the system here that this is going to be just a fixed width 80 character card reader. So that's going to be what? Record format is fixed block. The LRECL, logical record length, is 80. And the block size is 80 because each card itself is just one unit that we read at a time. And then XMIT out is where we want receive 370 to put the contents of the transmit file that is reading here. So this is going to be, we'll make a new data set, we'll catalog it, and we'll delete it if anything goes wrong here. And I'm going to drop it, let's see, this is going to be HMVS01, and we'll just call it, we'll call it file, what was it, 605, 607 for, just to match the CBT file name. So HMVS01, file 607, that looks good. We'll need to give it some space. I don't think this was very big. Let's give it like 15 tracks, maybe. We'll say 15, grow by increments of 5. It's a partition data set, so it needs some directory blocks. And if we overestimated the space, we'll just release any unused space back, back to the operating system, back to the disk. So in this case, it's a lot more convenient to overestimate than to underestimate and have the job fail and have to clean up and do it again. So that's good. What else do we need? Does it need a data control block? We'll do one to be safe. So this is going to be, again, fixed block. LRECL will be 80. This will probably land on a 3350 disk. So block size of 5600 makes sense. And this is a physical organized. It's a partition data set as implied by the directory blocks here. So organized as opposed to sequential data set. I think that should work. Let's double check this. We're reading from the card reader, and we are going to put it at hmvs01.file 607. We got some space, DCB. Okay, let's submit this and see what happens. Okay, start our spooled output viewer. Job not run, JCL error. What did we do wrong? Let's page down here. Oh, programmer name missing on the job statement. Okay, let's purge that, switch back. So again, I'm used to my own system where I set up the JES2 classes to never require account number or programmer name. But in the default setup here, we'll just add an account number, and I don't know, I'm Wilson. We can add my name. Okay, so those are required for Class A jobs, the way the system is set up. So let's submit that again. There we go. And I will switch back over to the output queue, and let's look at this one. Still JCL error. Unit field specifies incorrect device name. Okay. Our unit is O1C. That's the... Oh, we didn't put a unit on our transmit out. Right. This can just go on any direct attached storage. Third time's the charm. Submit. And there we are. Okay, that's what we like. We have a return code of 0 here, which is success. So now if we page down, we'll see, yes, that Receive 370 was able to copy all of these members from that transmit file. Perfect. So we'll purge that job. Now if I switch back over and go to our dataset list again, we now have file 607. So let's go ahead and browse that. So the Ind-File package itself is this Ind-File member, and this is another transmit package. So for this one, we just need to receive its contents, and we're just going to stick it all straight into sys2.commandlib, and that will make all the contents of this member available as files or as commands from the TSO prompt. So we can do that. We can actually just go back to our JCL here. Let's say install Ind-File. And I'm going to start by copying the contents of my receive job. We'll rename this I for install. Now this time, instead of the card reader, our input is just going to be an existing data set at hmvs01.file 607, and it's that $file member. And our output, again, this is an existing data set. We're just going to stick it all in it was sys2.commandlib and delete these two lines. So this is really simple. We're receiving from this transmit package, and the output is going into this existing data set. So let's submit that. Go over to our output queue, and it was successful. Return code of 0. So let's go to the bottom of this and just look at what it did. And there we go. We got our Ind-File executable, and then we also got the programs it uses to do code page translation. So at this point, I'll purge that job. We should have the capability of using our 3270 clients send and receive file capability. And like I said, we'll use that later. So we had to get that sort of prerequisite out of the way here. Perfect. Okay, now on to RACF itself. So let's go over to the CBT tape website again. And if we search for RACF with a K, we can see that file 850 is the RACF security system for MVS 3.8. And that's what we want. Everything we need is in this tape from, or I guess this transmit package from the CBT tape archive. So let's copy that link and go back to our shell. And once again, I'm actually going to make a directory here just to hold our RACF stuff. So in our RACF directory, let's download that CBT file. And we'll unzip it. And there's our file. So file 850.xmi, so it's another package we can receive with receive 370. It looks to be a little over 4 megabytes large. So when we're allocating the space for the new data set for its contents to go into, we can keep in mind that this is a roughly, again, let's call it a little under 4.5 megabytes of data. So if you haven't had to sort of estimate this stuff before, just a little diversion here. Let's go back over to that web browser. There is a page, if I make a new tab here, and if I just search for mainframe disk capacity, I think table, this will probably find it. Yeah, so on the site ibmmainframes.com, I have this page bookmarked. It's probably one of the most useful pages on the entire internet. This shows you for each type of disk what the physical sort of geometry is of the disk in the terms that MVS actually uses. So cylinders and tracks. So if I look at the 3350, which is the disk that we'll use for just a lot of our scratch work here, you can see that one track on a 3350 is a little under 20K. And then one cylinder has 30 tracks. So one cylinder gives us a little bit over 0.5 megabyte. And there's always going to be extra overhead when you're dealing with the mainframe because of how it blocks the data. And part of the equation of determining your block size is minimizing wasted space for the type of records you have. And that's a whole other discussion. As always, the mainframe world is quite complicated. But there are utilities. Moshix did a video on it, and I think he has some Go code in his GitHub repository. But if you know your record length and you know your disk type, those utilities are, right, they're using this information. They just have it built in for the particular disk type to determine sort of the most efficient way to store data. But sometimes you're not just going for storage efficiency and space. There might be performance implications. The point here is if we have a file, we know that essentially for every 0.5 megabyte of that file, we're going to need a cylinder of 3350 space. Again, if you're working with 3380s or 3390s, that's going to be different. A cylinder holds a different amount of data on different types of disks. But this, I happen to know, is going to be going on a 3350. So figure about a cylinder per 0.5 megabyte. All right. So even though we have Ind-File available and we could send this transmit file up to our mainframe through our 3270 emulator, let's just go ahead and read it through the card reader again, because we don't actually need the transmit file on the mainframe. We just want the contents of the transmit file. And it's really convenient to read these kinds of files in through the card reader. So let's go back to Hercules and load that file. We put it in the RAKF directory. So now it's RAKF file 850. Okay, so that is now sitting in our card reader at O1C. And if we go into our TSO session here, let's do this again. And I'll just keep making new data sets so we sort of have a history of what we've done. This is going to be receive RAKF. And again, I'll just copy my receive Ind-File, since that's basically the JCL we already want. It already reads from the card reader. Instead of file 607, let's go file 850. And this time we said, I'm just going to do cylinders because this is a larger set of data. We said about a cylinder per half megabyte, and we said this file was what? A little over 4 megabytes. So 8 cylinders for about 4 megabytes. And again, let's overestimate and just give it 10 cylinders. So let's say 10 cylinders will grow by 5. We do need directory blocks. And again, we'll release. So if we've overestimated by a gross amount, that space will be returned to the system. And I think that's it. That's the only modification we need. So again, we're going to read from the card reader where we put the file 850 transmit package that we downloaded from the CBT tape site. And we're going to put it all into hmvs01.file850. So let's save that. Let's submit that job. And did I close out my other session? Yeah, so I'll start another 3.8 window here. Let's look at this. Okay, perfect. It worked. So we got a return code of 0. If I go down to the bottom, we can see that sure enough, a bunch of files here have been loaded. I guess I should use the technically correct terms. A bunch of members have been loaded into our new data set. So we can purge that job, hit F9 to switch back over to our other window. Now, if I back all the way out and I use my dataset list again for HMVS01, we now have file 850. So if I browse file 850, here we are. We have all of the files packaged up that we will need for RAKF. So let's take a minute to look at this. Originally, the RAKF files for MVS 3.8 were targeted at the TK3 system, so the old predecessor to TK4-. And they were distributed, the various pieces, as individual zip files in the old Yahoo groups. I don't know if it was the MVS H39 MVS or if it was the turnkey Yahoo group, but that was one of the places they were originally packaged up for, as a set of zip files. And so to package them up for being included in the CBT tape, there were some changes to how they were packaged. And probably the biggest one is that the tape, the actual AWS tape image that just would have been a zip file download from the Yahoo group, is now included in the bundle of members that you get with the CBT tape version. So this file right here, AWS tape, is an actual tape image, right? We can get that onto our system, and you can tell Hercules to load this into a tape drive. And that, in fact, is how we are going to install RAKF. So you can read through the various docs here. Again, there's notes over time. You can see there was a conversation between one of the earlier authors of RAKF and Jürgen when he was putting together, I believe, TK4 and helping package this all up in sort of the CBT tape form. So interesting history here. always nice to see the community members working together to put together these, really impressive free resources for us, so that we're able to run our old MVS 3.8 mainframes as if they have nice, modern, full-featured commercial software. And I believe this @file 850, yeah, so this is sort of the description from the CBT tape archive itself. So Craig Yasuna was the original author of what became RACF with a K. It was the ESG security system. And then you can see here over time, these folks all worked to modify it to both make it work with MVS 3.8 and get it packaged up here so that it is reasonably straightforward to install it on our MVS system. And this is where you would find out, oh, okay, so the tape is in here as member AWS tape. And here's the naming convention for the PTFs. So all those patches, there are 6 of them. So RAKF 001 through RRKF 006. Here's a description of what those are. So good information here. And the other really important piece here is that there are up-to-date members with the documentation. So we will want to grab the PDF of the documentation because that will tell us how to install it and how to do the rest of these steps. So that is good to know. So we want basically 2 of these members we need to pull down to our Linux system. We need AWS tape because that's a tape image that we are going to mount in Hercules so that the various install jobs can read the RACF installation materials from that tape. And we are going to grab the, let's see, where was it? Here it is, RACF doc pound is the PDF version of the documentation. So I'm just making a note here on a pad of paper, RACF doc pound. Okay, let's grab those files. And this is where we'll use our newly installed file transfer capability. So you need to be at a TSO prompt. Being in option 6 of RFE should work, but I always, just as a habit, I exit all the way back out just to the actual TSO prompt. And if you're using like Vista 3270 on Windows, there's a menu option. But in C3270, you can just hit the escape key, which is Control and then closing square bracket. So this character right here, Control, closing square bracket. And that brings you to the C3270 prompt. And you can just type transfer to begin the transfer. And this will ask you some questions. Do I want to continue? Yes. I want to receive a file. So you can just hit enter to accept the defaults. Name of source file on the host in single quotes, HMVS 01. And that was file 850. And then the member name, remember we need 2, so we'll do this 2 times. But the first one we'll grab is the tape. Okay. And where do I want this on the workstation? So I started C3270 from the MVS 3.8 directory. So we made a RACF subdirectory. So I'm going to say RACF, and we'll call this, I'm just going to call it RACF.aws. So I have my RACF tape, and it is a TSO host. We want the tape to be a binary image. We don't want it to try and do ASCII translation. And then this is, should it overwrite a file? And you can just hit enter through this. So do I want to continue? Yes. Okay, file transfer in progress. Hit enter to resume session. So you can see here it's transferring and it finished. So let's do that one more time for the documentation. I'm going to hit Control square bracket, transfer, yes, receive. So this time it's MVS 01 file 850, and it was RACF doc pound. And on my local workstation, I'm going to call it RACF.pdf. And the rest of these, it'll remember my settings from last time, so I can just hit enter through the defaults. Again, this is a binary PDF file. We don't want to do ASCII translation. And it's transferring the PDF, which may actually be larger than the installation tape itself. Indeed it is. In fact, quite a bit larger. Okay, there we go. So we got the PDF. So let's go over to our shell. And now if I look in my RACF directory, we have the tape and we have the installation PDF. So essentially, for the rest of this video, I'm just going to be walking you through following the steps in the installation PDF. So let's go to, I'll just open that PDF up in Firefox here since I have a web browser open here. New tab. Let's open. That was, where am I? Oh, of course. Sorry. This is the wrong system. I'm SSH'd into this box called Hercules. So of course I just downloaded the PDF to the remote system, not my local system. So we are going to take a quick detour and we will just run a terminal here. So I need to copy that. So from that remote system, and that is MVS 3.8 /RACF/RACF.pdf. I need to get that to my local system so I can actually open it up. Okay. Sorry about that. So yes, you do actually have to have the, I lost my screen here. Here we go. You do actually have to have the PDF on the system that you want to read it on. So now I have, there we go, RACF PDF. Okay, a security system for MVS 3.8J, user's guide, perfect. And yep, so again, this is the latest documentation because it knows that we are up to 6 PDFs. Now, if you're interested in RACF, if you're going to install it and use it on your system, I recommend reading through this entire PDF. There's good and interesting information in here related to what usernames batch jobs, started tasks are going to start as. It's interesting, this RACF indicator is actually sort of a flag on data sets that tells the operating system whether or not that data set should be protected by the security system that you've installed. We'll touch on some of this in part 3 of the video series, but it's only 30 pages here, so it's worth a read on your own. But we will jump right into the installation. It's all packaged up as SMP system modifications. So it's a nice, well-packaged piece of software for the mainframe that uses IBM's software management tools to apply it to your system. And we'll just start going through the instructions. So the job RACF 12 is on the CBT tape. You can see the document has been updated, so we have instructions both if you're installing from the CBT tape or if you grabbed the files from the Yahoo group back when the Yahoo group was around. I believe most of the files have been transferred over to the new Groups IO group, but I like just having that all in one CBT tape package. So the RACF 12 job is going to receive the installation jobs from the tape. So if we go back over to our TSO session here, we'll go back into RFE 3.4, and in our file 850 here, there it is. We can see there's this RACF 12 member. So let's edit this. So this is going to read the files from the tape, and it will put them in a new data set called racf.install.control. So this reminds me of something else. So we are going to be creating quite a few new data sets that have this RACF prefix as the high level qualifier. Now, typically, when you were doing that, you would make an alias pointing the RACF HLQ to one of your user catalogs. Right. Generally, you don't want to be cataloging data sets in the master catalog. You want to catalog them in user catalogs. But RACF is going to be a pretty integral part of our system. We're going to install it on our sysres volume, the MVS res volume. And no matter what happens, whenever we IPL our system, we want RACF to work. So we are going to catalog all of the RACF data sets in our master catalog. Now, the way the Moseley system is set up, there's an update password on the master catalog. So every time you try to change it, it will prompt you for the password to modify the that particular vSAM cluster, the master catalog. And after we install RACF, we're no longer going to depend on the catalog update password. We should theoretically be able to set up RACF such that users can't just create random named data sets wherever they want, right? Typically, users can only create data sets that begin with their name as the HLQ, or the groups they're a member of, or other HLQs that they've been granted access to. So we're not going to be concerned about users trying to catalog data sets at random HLQs that we don't have aliased into user catalogs. So the reason I'm saying all this is justification for the first thing we're going to do here before we dive into the RACF JCL is we are going to remove the update password from the master catalog. So to do that, we just need to write a little bit of our own JCL again, not surprising. So let's edit, we'll call this no catalog password, no cat PW. So HMVS01 job, I'll do the account number and programmer name, and then message class equals X. So this is going to use the control program for access method services, IDCAMS. So we'll just call it IDCAMS exec program IDCAMS. And I'm not sure if the default region is large enough. Let's just give it a 1 meg region. Let's see if I can remember all this off the top of my head. We're going to want, I believe it needs a sys out, or is it sys print DD? And that's going to be sys out equals star. And it's going to need a sys in DD. These are going to be our instructions to it. So the command to remove a parameter, in this case, the password, it's going to be alter. And does anyone remember the name of the master catalog? Let's go and look. So in the JCL that was used to generate the system, I believe that was done in the MVS 01 step. So let's just look at that. And there it is right at the bottom. Yep. So here's where the password was added. Alter sys1 vsam master.catalog, and we set the update password to sysprog. So let me just copy that data set name. And if I go over here, we will say, we'll paste that. And then to remove that, there's a nullify parameter. So we're going to nullify the update password. All right. I think that's all we need to run a simple IDCAMS job. So we're going to alter that. That's the sysin. We said sysprint. So let's submit that. Oh, did I not put a job name character? Okay, well, we'll call it P for password. There we go. Oh, yeah, I didn't insert it. We could have done a P there. Okay, so we got a prompt over on the console. So let's go to the console. And because we're modifying that data set that currently has an update password on it, we need to give it the password. So, right, we can't change it without giving the password, and removing the password certainly counts as a change. So the password is sysprog, and it asks us one more time. There's probably somehow 2 operations involved in actually making this happen. So we'll reply 3 sysprog, and we got a 0 return code there. So that looks good. Okay. So now when we run that job to set up our first of many RACF data sets, which is $RACF12, it should not prompt us for a password, even though this is going to be cataloged in the master catalog. So let's look at this job really quickly, make sure it's doing what we want. RACF install, class A is fine, X output class is what we want. And it's, again, going to read from this tape, and it will create this data set, RACF install control. We can make this anything we want. I'm going to stick with everything in the top level or the high level qualifier RACF. It sets this up with one directory block. I'm going to use this data set to hold some other JCL that we're going to have to write. So I'm going to give it a few more directory blocks. Otherwise, we will quickly run out of space and have to always be fighting with compressing the data set and all of that. Space-wise should be fine, though. So again, because we're going to use this data set just to write some extra JCL later on, I'm giving it more than just one directory block. That would be way too tight. And then we can see that it is just copying from tape these members. So yeah, that's the end of the job. So that should all work. Let's go ahead and submit this. Okay, RACF12. So we have a bell in window 1, and that's because the system is asking us to please mount the tape RACF12 at device 100. So I have a tape drive at device 100. That job said, hey, I'm trying to read off of tape RACF12. So let's go to the Hercules console and devinit device 100 with the RACF AWS tape. Okay, and let's go back to we can just cheat and look on the MVS console here. You can see that this job finished with a result code of 0. So it was successful. So back over in TSO, let me start up our output browser. And if you go status star, you'll see jobs, all jobs, not just the ones that have your username before them. And if we go down to the bottom, we can confirm that, yep, that RACF12 job, if we select that to look at, exit code of 0. And if we check the bottom of the job, you can see that, yes, indeed, those members were all copied into our new data set. So we're going to be looking at this all jobs list quite a bit. So just to help our future selves out, I'm going to purge all of these jobs. Oh, yeah, I don't have the sysmod installed that lets me do that as a regular user. But I believe the Q program will let me do it. So if I go held output, so this is all held output from the system. So again, I'm just going to purge all of these so that when we look at that list from RFE, okay, it won't be cluttered up with all those other jobs. And then I'm just going to keep all of our RACF installation jobs for now, just so that if we want to go back and look at them for some reason, they're there. We don't need to be super fastidious about cleaning up all of our jobs as they happen. We just need to clean them up before our Jez2 spool fills up, which won't happen from just the RACF jobs we're running. Okay, I hope that made sense. But now, if we look at our new RACF high-level qualifier, we have our RACF install control jobs here. So what do we have in here? It looks like we have some installation instructions. This may be out of date. Use the PDF, not the instructions here. And then we have jobs to prepare, and this is creating all of the other RACF data sets that everything will get copied into by SMP. We'll receive the product material, we will apply it, and then we can accept it. So receive, apply, and accept are SMP terms for actions that you take with that package management system modification program in the mainframe world. But we're getting a little ahead of ourselves. Let's look back at the instructions. So we ran job RACF 12 and we submitted it. So step 2 is we're going to edit these prep, apply, and accept jobs. And in the prep job, you can see only in job A prep, we need to make the space allocation for these sample libraries larger. And this is because the 6th PTF will install new versions of the documentation, and it doesn't fit in what the original prep script was allocating here. So let's do that first. It wants 120, 40, 10. So let's go back over here. Let's edit that prep job. We want to find its asamplib and samplib. And it says we should now use, what was it, 140, 20, 10, 140, 20, 10. Make sure the parentheses are there. And then samplib is right under it. So that's also going to be 140, 20, 10. Okay. Yep, 120, 40, 10. And then it notes here that since we're already making these bigger, we don't need to follow the special installation instructions in that PTF number 6. So change all occurrences of HLQ to the desired high-level qualifier. So we're just going to use the bare RACF. We're not going to use RACF with the version number. So we can do that. So you can see there's a lot of HLQ.asamplib, HLQ.samplib, HLQ.amaclib. All of these HLQs need to be changed to RACF. So let me go to the top of this. And in RFE, or the review editor, you can use the C command to change. And then in quotes, I can say change HLQ to RACF. And then the all qualifier will change all instances in this member. And you can see it brought us to the first change it made, and then you can see that it made the change throughout the rest of the member here. Okay, easy enough. Now it says change all occurrences of DDD to the desired volume for the RACF distribution libraries. So sticking with how this system is set up, we will change lowercase DDD to SMP000. That's the disk pack in the Moseley setup that holds our SMP distribution libraries. And again, we'll change all of those. And you can see now that all of the distribution libraries, which are traditionally the ones prefixed with A, have changed to volume serial SMP 000. Next step, change all occurrences of SSS to the desired volume for the RACF target libraries. So these are the actual installed RACF files that our system will be using. And like I mentioned before, because RACF is going to be so integral to the operation of our system, I'm going to install it on our MVS res volume, so our system residence volume. So we can do that by saying change SSS to MVS res all. And now you can see that the target library version, so without the A prefix, they're now being created on MVS res, which is what we want. And then change all occurrences of TTTT to the device type and all occurrences of RRRR to the volume of the sysres device where sys1 LPA lib and sys1 link lib of the system residence on which RACF is to be installed. Okay, so again, for us, because we're installing on MVS res, this will just be the same. It'll be MVS res again. But if you're on the TK3 system, they give you the hint, hey, it's a 3350 disk and MVS res. That is also the case for our Mosley sysgen. So TTTT and RRR. So I can change TTTT to a 3350 device. And then here you can see all the places where that RRR is used. And this is actually, it looks like this is just cleaning up any other versions of RACF and the user exits that enforce security decisions on the system. But we'll just go ahead and change RRR to MVS res and make that all. So as this, let's go up 5 here. Yeah, so these are basically just commands to delete from the existing LPA lib and link lib if these members exist. Okay, so that's it for the prep job. And then it also said that in members C apply and C accept, we need to make the same changes. In reality, if we look through this, the only one of those strings that we need to change is that HLQ. There are no, SSS, SSS, or RRR, or any of those other things. So we can just change HLQ to our desired HLQ of RACF. And then we make the same change in D-accept. Change HLQ to RACF on all of the dataset names here. Okay, let's look at the next step of the instructions. So here it says, verify that in jobs apply and accept, the sequence of the syslib and the target and distribution library DD statements matches your SMP apply and SMP accept procedures. The jobs have been tested with the SMP procedures as defined in the TK3 system. So what in the world does this mean? So let's look at the apply job. And if we scroll down to here, you can see that we're using a cataloged procedure called SMP APP for apply. And one of the DD names in this procedure is syslib. And we are overwriting the syslib DD with this syslib concatenation. So lines 20 through 25 here. Now, what that instruction is saying is that we need to make sure that we have the same number of lines in our syslib concatenation here that there are in our cataloged procedure, because we essentially want to just clear out all of the data sets in syslib except the RACF maclib. And apparently the way that DD name overrides work when you are invoking catalog procedures or even inline JCL procedures is it's basically line for line. So if there are 10 lines of syslib, concatenations in this procedure, we will have overridden the first, the second, the third, the fourth, the fifth, and then the sixth will overwrite with this. But then the 7th and 8th and 9th and 10th will still be there from this procedure. So we need to make sure, essentially, that we're overriding all of the lines of the syslib DD that are in SMP APP. So, well, how do we know how many there are? We just have to go and look. So I'm going to start a new dataset lister. And SMP APP is in sys2.proclib. on a Mosley system. So let's look at that. And there it is, SMP APP. Let's go ahead and take a look at that member. And if we go to, actually I'll use view so we get syntax highlighting. It looks like the other screen. If we go down and we look for syslib, here it is. Now, how many lines of syslib are there? 1, 2, 3, 4, 5, 6, 7. So we just need to make sure that we're overriding 6 lines, and then our 7th line override is that RACF maclib, whatever we want. So we can exit out of this. And what were there? 1, 2, 3, 4, 5, 6. So we just need one more line here. So I'm just going to copy this line and put it before this line. And now, as the instructions say, we have verified that the sequence of the syslib and target and distribution library DD statements matches your SMP APP procedures. So the same logic actually applies to maclib and samplib and sourcelib, but I'm pretty sure those were already only one line in the other. I guess we should have looked when we were there. That was SMP apply. So let's find, yeah, like if I find samplib, there's only one line for asamplib and one line for samplib. Same thing if we do maclib. There's only one line for maclib. So that syslib is the only one that has multiple that we need to override. So that's all taken care of. We need to do the same thing in the accept job. Now, another note is on this system, we don't have a separate accept catalog procedure. We just use the apply catalog procedure to accept the changes as well. And so again, since it's that same procedure, SMP APP, we know already that there are 7 syslib lines. So how many are there here? 1, 2, 3, 4, 5. So we need 2 more. So I can just do a block copy of these 2 lines and put them before this line. Now we have 1, 2, 3, 4, 5, 6, 7. So those are all the modifications to the installation JCL that came packaged up on that RACF installation tape. So let's go back over to the instructions here and continue. Okay, we'll submit a prep. So basically, if we just read through this, we're going to submit a prep that deletes things, that deletes the placeholders that are there for the security product. And then it will create our target and distribution libraries. We will then receive the RACF materials by submitting the receive job, and that's going to read them from that tape again. We will then apply those products with the apply job, and we'll just go ahead and then immediately accept the product with the accept job. In a real production scenario, right, you can apply it without accepting it, and that lets you essentially roll back changes that are made from SMP. But because this is just the base version of RACF, it's a new system, we haven't had it before, we'll just apply and accept kind of in one fell swoop. So let's do that. At this point, because we already modified all of these jobs, we're just going to submit them one after another. You can see here on step delete, we do expect a non-zero return code. We expect code 8, and that is because we're trying to delete things that don't exist. So that's normal, that's expected, as long as we get zeros for the SMP step and the creating all of our data sets step. So let's submit that. Okay, job 20 is submitted. Start our good old 3.8 output browser, look at all jobs, and the prep job finished. And as expected, we got the first 2 jobs with a return code of 0, and then that third job with a return code of 8, which is exactly what we expect. So that was successful. So I'll hit F9 to swap back over to my other window, and we can run the receive job. So let's look at that one more time. So this is a simple job that's just going to receive all of the system modification data from tape, and it will receive it into SMP's pool of installation material that it has available to it. So when we submit this job, we should be prompted on the console. Switch over to the console for the RACF tape again. This time, MVS is asking for us to put that tape on tape device 101. So over here in Hercules, I'll just use the up arrow to get that devinit command again, except this time it wanted it at address 101. So we'll mount the RACF tape on the tape drive at device address 101. And that should satisfy that operator prompt. It does. And again, without even looking in the spooled output queue, we can see that that job succeeded with return code 0. So now we'll apply it. So this is the step that's actually going to install the RACF materials into our system. So if we submit that job, okay, submitted. You can see we're expecting a return code of 4 or lower. And if we swap over to our output queue, there we go. We got a 4, which is exactly what we expected. So if I go to the bottom of this job, you can actually see the output from the system modification program where each component of RACF is applied and where it was sent. Some of them are, or a bunch of them are in source lib, some of them in the Mac lib, some in the sys lib, some in the sample lib. And if we go up sort of the top of this, we will see, there we go. So the whole function called RAKF120, that's the name of the overall RACF package, was applied. So that all looks good. So swap back over here. And the last step, again, like I said, we'll just go ahead and immediately accept all of those. So those will put sort of the golden copies in the distribution libraries so that if we do apply the PTFs and then we want to get back to what was the material before the PTFs were applied, we'll have them in the distribution libraries until we accept the PTFs. So let's submit this job. Okay. And again, I don't expect any problems here. Let's take a look at the output. And we got return code 0, which is success. So if we go into the bottom, now instead of applied, all of these say that everything has been accepted into the distribution libraries. So the version of the libraries that have that A prefix. All right. Let's look at the instructions one more time. So after this, we need to perform a CLPA IPL of our system. So some of these, basically these RACF exits get installed into the link pack area because they're always being used by the system. They're always available to the system. So we need to rebuild the link pack area. So we'll re-IPL the system and then we'll be able to check that it actually got installed because it is going to display a RACF banner at the beginning of our IPL. So I should note RACF isn't activated at this point. It will not enforce any security decisions. It will just let everything pass through. So it's still basically safe. We're not going to lock ourselves out of anything on our system. So to re-IPL the system, I'm going to log out of TSO here. So just keep hitting F3 until I'm back to the TSO prompt, and we'll log off. And over on my MVS console, we'll just start our shutdown procedure. So that begins by stopping TSO. And then with TSO stopped, we can stop VTAM. So that's znet, quick. And all available functions complete means that there's no other jobs that Jez2 is running. So you can shut down Jez2, which goes faster if you shut down all the initiators. I was complaining about how long it took sometimes to actually get the Jez2 shutdown complete message in a previous video. And somebody, with apologies, I forget who, but somebody mentioned that if you just stop all the initiators first, then the $pjez2 step, rather than hanging here at log not active for a while, will quickly then transition to jez2 termination complete. Then we just do our z eod and quies. Okay, so over in Hercules, we don't need to quit Hercules and restart or anything. We can just IPL 150 again. I always say IPL clear. I think that just, I don't know, clears some registers or something before it tries to IPL again, but I think either way works. Okay, so now we just IPL our system like normal, except we want to rebuild the link pack area. So to this all-important IEA 101A message, we say reply 0 CLPA. All right, look at that. It looks like we successfully installed RACF because our system is now printing out this little RACF banner at IPL time. And like I said, it does tell us RACF is not initialized. We haven't actually told it to start enforcing security yet because we haven't, among other things, defined any users or made any profiles. So that's good. So we'll just go ahead and continue IPLing our system like normal. We just reply with U to this 0 message, and then a normal warm start of jez2. At this point, we hit F12, so we get the console in roll mode. And once everything that starts up automatically has started, we start VTAM by doing snet. And that's it. Our system is back up and running and ready for work. So we'll just confirm if we log back in as HMVS01. That's great. We still got into TSO with no password because there's no TSO password defined on this user. One of the things you'll see with RACF is that users require passwords. So one way we'll be able to tell if RACF is working or not, like actually active or not, is that we will start getting prompted for a password when we try to log in as HMVS01. Again, even though the TSO user database does not have a password set for this user. So the one last thing the instructions said we could do is check the service table to see if these RACF services are installed. And we can do that with the T option in IMON. Now that I think about it, I don't think we have IMON installed. So we're probably not going to be able to do that. If I run, yeah, it's just IM. So IMON isn't installed by default. It's a simple installation because I think it's just a big card deck that has all the assembler and everything in line. So if you do have IMON installed, you can use the T option and you will see the rack services installed there at 130 through 133. But I'm satisfied that because we saw that banner at startup, we know that everything got installed. And if we look back, let's go in RFE and look at our RACF. You can see there's a bunch of RACF data sets here. You can see the maclib are some of the assembler macros it uses to build itself. The source, so here's the source for all of those RACF exits that got built and installed into the LPA lib area as part of the RACF installation, as well as these RACF profile and user commands got installed in, I think probably sys1 link lib, if I remember correctly. And then the samp lib has a lot of the materials we had from that installation package on the tape. So again, the samples of the installation jobs, a couple other sample JCLs that we're going to use, some samples of the profiles that we'll create, and then documentation members here from the original version. And some of the PTFs will actually update some of these samples. So that is part one. We have installed the base version of RACF. Was it V1R2? If we go back over the top here. Yep, V1R2 modification 0. We still have 6 PTFs to apply, which is going to be the part 2 video. And then again, part 3, we will actually customize RACF and turn it on, and it will start enforcing security on our system. So thanks so much for watching. If you have questions or comments, drop them down in the comments below. I plan on releasing these videos just one day at a time, one after another. So if you're watching this on the day it comes out, part 2 should be out tomorrow. If you're watching this in the future, all 3 of the videos should already be ready and waiting for you to watch. So I will see you again very soon in part 2. Thanks again for watching.